All right, section 4.3, more structure of the atom on how we're going to use it. This section you're going to need to get your periodic table. You're going to be using it. You're also going to need a calculator, so make sure you have both of those two things ready. If you don't, stop us now, go get it, come back, and continue.
Yes.
All right, so here we go. How do the atoms actually differ from each other? So we've got this periodic table, which you've used in the past, and you've got a bunch of atoms listed on here. How do we know which atom is which? What's on here? How do we use it? Well, Henry Moseley found that each atom had a unique positive charge, so we can identify atoms based off of the number, which we call the atomic number. So on your periodic table, the one you should be getting, it looks just like ours. You might not be able to see it off of this video cam, but you're going to be looking at the blue top left corner of your periodic table. That is going to be your atomic number. That is the number of protons. Since all atoms are neutral, you must also have an equal number of electrons. So your positive charges and your negative charges have to equal out to each other. So this number in the top corner has to be the same. So your atomic number equals the number of protons plus the number of electrons, okay? They're the same thing. They're not actually added together. They're the same. So if you're looking at calcium, calcium's atomic number is 20. That means that there are 20 protons and 20 electrons. All right?
When you look at other periodic tables, they will not be arranged the same way. A lot of periodic tables are different. You will always have a key, like you have on your periodic table down in this corner. It will tell you where the atomic number is. Your atomic number is always going to be the large number, probably in an upper left or right-hand corner. So on our periodic tables in our room, they are the upper right-hand corner. They're the red numbers.
All right, ready to do some example problems?
Yeah.
Awesome. So we're going to use our periodic tables. We're going to find our carbon atom, which is, hopefully you can remember this from your Science 1 class. Carbon, we're going to look at carbon, and we're going to find out how many electrons and how many protons for each. Now I kind of like to write down P plus and E minus so that they kind of get used to writing those combinations.
Yes.
So for P plus, Mrs. Kelly, I'm going to find carbon, and I found the atomic number is going to be 6, which tells me the P plus protons is also going to be a 6. And then my electrons, E minus, is going to be 6 as well.
Good.
Easy problems, people, easy. All right, we're going to find nickel, which is Ni. It's number 28 on our periodic table. The proton number, if it's 28 on my periodic table, is 28. Yeah. And then our electron number is also the same.
Yeah.
28.
Uh-oh. What happened?
Oh, we'll go forward. There we go.
There we go. Okay.
E minus.
28.
28.
Okay.
Easy peasy problems.
You should be able to do that for any element on the periodic table. You can figure that out for any of them. We went over that in Science 1, in case you didn't have me. You would do that for any of them. Okay?
Yep. Identify the atom containing the following number of electrons. So here they're telling you, you have an atom with 34 electrons. What are we going to do?
We're going to look for the atomic number that is 34.
All right, so
Notice they all go in order. So if you know where 30 is, you can go 4 over and you'll find 34.
We hope.
We hope.
All right. We have selenium. Se is 34. So all we need to do is write down its symbol, Se.
Yes.
And then we have an atomic number of 5. And 5, we're going to look on our periodic table in order, is B for boron. Not a moron.
Not a moron.
Just a boron.
Just boron.
All right, the next one's identify the atom containing the following number of protons.
Yes.
So if we've got 74, looking on our periodic table, we're going to find it to be tungsten.
Ooh.
Tungsten has
You guys
nothing
know what
to do
symbol
with the
it
T.
is?
It's a W.
W.
Bloop, bloop, bloop. And it's also in light bulbs. Okay. Oh,
Yes.
the old-fashioned that are,
Old
oh,
The filaments.
frowny face now.
Yeah.
Can't have those in your house.
Right.
All right, 20. 20 is going to be our calcium friend, Ca. So we just have to be able to read our periodic table for these problems. Pretty easy.
Yes.
I agree. All right, so isotopes. Ooh, what are isotopes, Ms. Kelly? That's a big word.
Well, isotopes are going to be the same element, but they have a different number of neutrons. Remember, neutrons are neutral. They do not change the charge of the atoms. So for carbon, you can have lots of different isotopes, but you will notice that they have a different number of neutrons. They will always have the same amount of protons.
So protons never changes.
Right.
What happens if I try to change a proton number?
You change your element.
So again, if we change the proton number, we're no longer the same element.
Right.
Why are we repeating this? Because we have seen many chem students try to change the number of protons.
Right.
If you change the proton number, you change where you are on the periodic table. So we never change proton number.
Right.
Okay, so we can change electrons and we can change neutrons. Never protons.
Right.
All right, so what do we need to do? How do we find out this isotope stuff?
Okay, isotopes, because they are neutral and they are not the same as the atomic number, you're going to look at the mass number. So
Ooh.
look on your periodic table. You will, on yours, the atomic number is in the upper left-hand corner, and then the small number on the upper right-hand corner is going to be your mass number. Now notice there are lots of decimal points there. You're going to round it to the nearest whole number. So let's look at carbon. Carbon has an atomic number of 6. That means there are 6 protons. Look at the mass number. It is 12.01. We're going to round it to 12. Okay, so your mass number is 12. Your atomic number is 6. So that leaves 6 neutrons. You're going to take your atomic number minus, you're going to take your mass number minus your atomic number to find the number of neutrons.
Ooh, can we use that full chemical symbol up in the corner to make that easy for us?
We definitely can.
All right.
Okay, if you notice that, let's see if I can use my little pointer here. 12, this is going to be sort of a circle. That is your mass number. 6 is your atomic number. If you take 12 minus 6, you get 6 neutrons. Okay, notice there it's the NO because the 0 means that it's a neutral charge.
All right, so the 12 was our protons plus neutrons. We took out the protons, which were 6, and we're left with our 6 neutrons. Pretty easy maths. So the mass number is the average atomic mass rounded to the whole number. So that's where we got our 12. So looking at your mass averages off of your periodic table, that's where they're going to get those big decimal numbers, right?
Yes.
So we've got some averages that we have to deal with. So let's go and work on a few of those, huh? All right, atomic mass is the weighted average of the atomic masses of all the isotopes ever found on that atom. You have a weighted average in chem class. Your tests are more of your grade than anything else. I think this year it's 70%?
Yes.
So 70% of your grade comes from your tests. So a lot of your grade, that's a weighted average. Not everything is the same. We're going to use that with our isotopes and figure out what mass needs to belong on the periodic table. So we can base stuff off of carbon-12. That was the standard that everybody used because there was a couple isotopes of carbon. Now here you see, Miss Kelly, they have carbon-12. Now this is a new thing that they've seen. What does that mean when it says carbon-12?
This means that it is the carbon-12 isotope. That means that your mass number is going to be 12. So if you look on your periodic table, carbon, the average atomic mass is 12.01. If you round it, that gives you carbon-12. It's just a different way of writing it.
Okay, so if it said carbon-14, we're not going to use the 12 off the periodic table. We're going to use the mass of 14 to maybe figure out how many neutrons we have?
Yes.
All right, so that's how we kind of write out our different isotopes. Our problem we're going to use. All right, you ready? You're going to need your calculators now. We have, I'll use that. You write, I'll use.
I'll try to write.
All right, your problem. Based off of element X's isotope. So at this point, we do not know which element we're dealing with. We have to figure that out. What is the average atomic mass, or the mass that needs to go on the periodic table in decimal form, and which element is it? So we have some information. They're telling you isotope 6X, so the mass is 6, and isotope 7X. So you have 2 isotopes for this element. The mass is 6.015 for X6 and 7.016 for 7X, which is where the 6 and the 7 come from. They rounded those to whole numbers.
Yes.
Now, percentage abundance. So in the universe, This is how many of those isotopes we would find. So only 7.59% of the time are we going to find isotope 6, X6. But 92.41% of the time, we're going to find X7. So if we were digging in the ground, or whatever element this is, if we take a sample of air, this is what we would find. How much abundance is it? Kind of like if you got a bag of Skittles.
Yes.
And you want to just the red ones, and you're hoping for a bag with a lot of red ones because it's your favorite. You're hoping that your percent abundance of red is higher than any of the other colors. So how do we figure out if we maybe wanted to put this element on the periodic table? What mass would we need to use? Here's your math. You ready? We're going to take our percent. We're going to take it out of percentage, which means we're going to divide by 100 or move the decimal 2 places to the left. 1, 2. All right.
Decimal point there.
Then you're going to take the other percent abundance for X7.
And that was 0.
Yep, on that one's going to need a 0. The 92.41%, you're going to drop the percent, move the decimal.
I'm just going to put your decimal there.
All right. That's step 1. Get rid of the percentage, make it into a decimal. Step 2 is to take the AMU mass and multiply it by your percent abundance. 6.015 times 0.0759 equals. So what we're going to place in that empty box right now is 0.4565. Now because these are pretty, the decimals go pretty far on your periodic table, we're going to try to give it enough decimals as well on our practice problems. The next one is 7.016 times 0.9241, and we get 6 point.
Uh-oh.
If
How do
you
we get out of there?
just tap. There you
Okay.
go. 6
Okay.
point.
Oh, 6. We'll just do this.
Ignore that one.
Okay.
6.4834.
Okay.
All right, so now we've got our kind of pieces to how much they're going to be involved in our weighted average, which you should have a higher number of the X7 because there's 92% of it found. So now all you have to do is you have to take those two numbers and add them together. So we get 6.4834 plus 0.4565 equals 6.9399. All right, so we've got our average atomic mass here. Now what we're going to do is we're going to look at that 6.9 and we're going to look on our periodic table and figure out what element X is. Well, 6.941, which is pretty darn close, is lithium.
So remember, you're looking at your average atomic mass here. You're looking at the little red number in the upper right-hand corner.
Yep. So we're going to have our element is Li, lithium.
Where should I put this?
Wherever.
Come on now.
L.
L-I.
There you go. You've answered both parts of the problem. Make sure you read the entire problem beforehand to make sure that you need to answer both, or if you're just finding the average atomic mass. Very easy. Percent abundance goes out of percentage into decimal form by dividing by 100, moving the decimal 2 spots to the left. Multiply that by the mass AMU. Get the two numbers, or 3. There might be 3 isotopes or 4 isotopes. Whatever those isotopes are, multiply them together.
We mostly don't go above 3.
I hope. And then add them all together, and you're going to have your weighted average that would need to go on your periodic table.
It may be helpful for you to make a chart like this because we will not have charts set up like this. It will be a word problem, and it might be helpful for you to set up your problems all like this so you can line it up.
I agree. And that's it for section 4.3. Have fun.